Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 2 from the June 2024 Statistics S1 International A-Level Edexcel paper. And here we have a question about discrete random variables. And they told us about a spinner which can land on the numbers 2, 4, 5, 7, or 8 only. And the random variable x represents a number that the spinner lands on when it's spun once. So these numbers here, 2, 4, 5, 7, 8, represent the random variable, okay, which is the number on which the spinner can land on when it's spun one time. Now, we have here the probability of each of these outcomes. And we can see that the probabilities are not the same. So it's not a uniform distribution here. That means this is a biased spinner. It's more likely to land on some numbers than on others. So the first part of the question says, find the probability that 2x minus 3 is greater than 5. Now this is something that's designed to just confuse you a little bit. You have to simply just solve the inequality for x and then answer the question as normal. So let's first of all do that. We have 2x minus 3 is greater than 5. We can add 3 to both sides. 2x is greater than 8. And we can divide both sides by 2. X is greater than 4. So basically they're asking us to find the probability that x is greater than 4, which means you're going to add these probabilities together. It means the probability that x can be 5 or 7 or 8. That's what it means here. So I'll just write this out for the sake of explanation. So it's equal to the probability that x equals 5 plus 7 plus 8. Okay, so that's 0.2 plus 0.1 plus 0.15, which gives you 0.3, 0.45. Okay, so there's the answer for part A. Okay, we could have also done 1 minus these two. 1 minus 0.55. It's not much of a difference. That's fine. Okay, now, then it says, given that the EX, which is the expected value of X, or the mean, is 4.6, show that the variance of X is 4.14. So what we should understand is that the variance of X, or the variance of something, is given by the mean of the squares minus the square of the mean. The mean of the squares minus the square of the mean. So the variance of X is going to be equal to E of x squared, the expected value of x squared, that's the mean of the squares, minus the square of the mean. So EX all squared. We already have EX, this is, we know EX is 4.6, so that will be something minus 4.6 squared. We got to find the expected value of x squared. Okay, so now the expected value of x squared is when you take the x values, you square them and multiply them by the probabilities, just as the expected value of x is multiplying the x values with the probabilities and adding them together. So EX squared is going to be basically 2 squared times 0.25 plus 4 squared times 0.3 plus 5 squared times 0.2 plus 7 squared times 0.1 plus 8 squared times 0.15. And that should give you EX squared. So as I just mentioned here, we're going to have 2 squared, whoops, that's not 2. 2 squared times 0.25 plus 4 squared times 0.3 plus 5 squared times 0.2 plus 7 squared times 0.1 plus 8 squared times 0.15. And that gives us 25.3. That's 25.3. Now, we've got to show that the variance of x is equal to 4.14. So as I said, the variance of x is the mean of the squares, which is 25.3 minus the square of the mean, which is 4.6 squared. So hopefully this will give us the answer that we are looking for. So 25.3 minus 4.6 squared, and that gives us 4.14, which is exactly what we had to show. Okay, so there's the answer to part B of this question. Okay, and now we're going to move on to part C. Okay, so for part B, part C, we are told that the random variable y is equal to ax minus b, where a and b are positive constants. So given that the expected value of y is 13.4 and the variance of y is 66.24, we got to find the value of a and the value of b. Now we were given this in the first part of the question. We were given ex and we were asked to find the variance of x. But now we've got to consider this coding that they've given us. So a coding is where this basically saying is y is equal to something times the x values minus, a constant, right? So you've taken the x values and you have transformed them, you have coded them, you could say, by a multiplication and a subtraction. So EY, remember, is something which is, basically is the mean of the data. Okay, consider the mean of the data. And variance of y is, of course, the variance of the data, which is something related to the spread of the data. It's the square of the standard deviation. If you take the standard deviation and you square it, you get the variance. And standard deviation, it's telling you about the average, you could say, distance of every entry from the mean value of the data. So it gives you an idea of how spread out the data is. So the variance is related to the spread of the data, and the EY is basically the mean of the data. Now, if you take some values, for example, if I have some numbers, I'm going to represent them by these dots. 1, 2, 3, 4, 5. So number 1, 2, 3, 4, and 5. And if I were to take these numbers and I were to add 1 to each entry, okay, then the new values would be, the 1 would become a 2, the 2 would become a 3, the 3 would become a 4, the 4 would become a 5, the 5 would become a 6. So these numbers would transform in such a way that the spread of the data would be the same. But the mean was 3, now it's become 4. This was the mean before, this is now the mean. So the mean has increased by 1, but the spread of the data has remained the same. So adding something or subtracting something to or from the data does not change the value of the spread of the data, but it does change the value of the mean of the data. Okay, so that's for adding something. Now, if you multiply, suppose we multiplied both or we multiplied every value by 2, for example. So 1 would become 2. Okay, 2 would become 4. 3 would become 6. 4 would become 8, and 5 would become 10. So as you can see, the mean, which was 3 before, is now 6. So the mean has been multiplied by 2. But the range before was between 1 and 5, which was also 4. Now the range is now between 2 and 10, which is 8. So the range has also been doubled. So the effect of multiplying each term by a constant will cause not only the mean to double, but also the spread of the data to double. Okay, so it affects both of them. So that's where we have to be careful here and in understanding how coding will affect the mean and the variance. Okay, so if we take the mean, so we have EY equals 13.4. That's what they've told us. From this, we can replace the y with ax minus b, because y is equal to ax minus b. So you have E of ax minus b is equal to 13.4, because this is the same as y. Right? Now, if you multiply each of the x values by a, and if you subtract b from that, then you'll basically, it's the same thing as taking the mean, multiplying it by A, and taking away B from the mean, because it affects both the multiplication and the subtraction affects the mean. Okay, so that's equal to 13.4. And we know EX is equal to 4.6 from what we've learned earlier, what they told us earlier. So we can say that this is EX, which is 4.6 times A minus B equals 13.4. So there's one equation that we have formed from this information given. Now we can do the same thing here with the variance of Y. So we know that the variance of Y is equal to 66.24. So we can replace Y with AX minus B. So the variance of AX minus B is equal to 66.24. Now, as I mentioned before, the subtraction part won't affect the spread of the data, so it doesn't affect the variance. But the multiplication part does. Now, the variance is the square of the standard deviation. And the standard deviation is what's like the spread of the data, you could say. So when you want to, thinking about the effect of this coding, the effect of it would be that you multiply the variance of X by A squared, okay? And you don't do anything about the subtraction of B. Okay, so that has no effect on the variance, but when you multiply each term by A, you have to multiply the variance by A squared. Why? Because the variance is the square of the standard deviation. That's why you square it. So A squared times the variance of X equals 66.24. That means A squared times the variance of X, which is 4.14, is equal to 66.24. So we can now find A from this directly. We can say A is equal to the square root of 66.24 over 4.14. Why? Because the variance of X was 4.14, as we learned earlier. So we're going to have the square root of 66.24 divided by 4.14. And that gives us 4. So we worked that out, that A is equal to 4. Now we're going to find what B is. Now we can just simply use this equation 1 here. We can replace the A with 4. So we have 4.6 times 4, and we can say minus 13.4 is equal to A. Is equal to B, sorry. Is equal to B. Just replace the A with 4.44, by A with 4, sorry, and we're going to subtract 13.4 from both sides, and that's going to what B is. So we're going to end up with what? So we're going to take this, multiply by 4.6. Okay, multiply by 4.6, yep, and then take away 13.4. And that gives us 5. So B is equal to 5. So if A equals 4 and B equals 5, and that is the answer to part C. Now for, I think, the last part of the question, part D, it says, in a game, Sam and Alex each spin the spinner once, landing on X1 and X2 respectively. Okay, Sam's score is given by the random variable S, which is equal to X1, which is the score that he gets on the spinner. And Alex's score is given by the random variable R, which is 2X2 minus 3. So it's basically 2 times the score that he gets on the spinner minus 3. That's Alex's score. So the person with the highest score wins the game. So if the scores are the same, it is a draw. Find the probability that Sam wins the game. Okay, so we got to find the probability that R is greater than S. We've got to find the probability that Sam wins the game. So S is greater than R. That's what we've got to find. Okay, the probability that Sam wins the game is going to be given by the probability that S is greater than R. That Sam's score is greater than the Alex's score. And they're given in different ways. So I'm going to put here, this is going to be S, and this is going to be R. Okay, so Sam's score is the same as what comes up on the spinner. That's going to be 2, 4, 5, 7, and 8, and that's the probability of those scores taking place. And the score of Alex is going to be given by R. So this is Sam, and this is Alex. Okay, so the score of Alex is going to be 2 times the score shown on the spinner minus 3. So 2 times 2 is 4, minus 3 is 1. 2 times 4 is 8, minus 3 is 5. 2 times 5 is 10, minus 3 is 7. 2 times 7 is 14, minus 3 is 11. 2 times 8 is 16, minus 3 is 13. So these are the scores that Alex will get if the numbers land on these numbers. That's the score that he will be assigned. So we got to find the probability that Sam wins the game. So let's consider the highest score first that Sam can get. Let's consider when Sam gets an 8, okay? And the probability of that is 0.15 times, and then you got to think of all the scores that will, will beat Alex's score if he gets an 8. So if he gets an 8, okay, and for example, Alex gets a 2, he's beaten him because Alex's score is just 1. So you're going to have 8 times, this is for Sam. So I'll do it like this so it makes it clearer. So I'll put here Sam, and I'll put here Alex. So if Sam gets an 8, okay, Alex gets a 2, okay, which means his score is 1, or a 4, which means his score is 5, or a 5, which means his score is 7, then Sam is going to be beating Alex. That's one scenario. Okay, another scenario would be if, let's see if I run out of space here. Another scenario here would be if Sam gets a 7, then Alex would have to get, let's see, if Alex gets a 2, he's beating him. If he gets a 4, he's beating him. If he gets a 5, they'll be equal, there'll be a draw. So Sam won't be beating Alex. So that's another scenario. Okay, so another scenario would be if Sam throws a 5. Okay, if he throws a 5, he's going to beat Alex. No, he's going to be the same. Yeah, he'll beat Alex if Alex throws a 2. Okay, so basically, if Sam throws a 5, okay, or a 4, or a 2, and Alex scores just a 2, then Sam is going to beat Alex. Okay, so if he scores a 5, or a 4 or a 2, he's going to beat Alex if Alex scores a 2 only. If Alex throws a 2, his number is going to be 1, and 5, 4, and 2 will be bigger than that score. Okay, so that is another scenario that we need to consider. So you've got Sam and Alex, so 8, 0.15 times for 2, 0.25 plus 0.15 times 0.3 plus 0.15 times 0.2 gets 245. Well, all of that can be combined into one because it's 0.5 multiplied by each of them. So you can do 0.15 times in brackets 0.25 plus 0.3 plus 0.2. Okay, the second scenario, if Sam throws a 7. If he throws a 7, then he's going to get more than Alex scoring a 2 and a 4, because 2 becomes 1 for Alex and 4 becomes 5, but 5 becomes 7, so we can't be equal to it. So basically, you're going to have a 7 is 0.1 times, and we're going to have 0.25 plus 0.3. Okay, and then the next situation is where Sam scores a 5 or a 4 or a 2. Okay, all of those will be less than what, so will be greater than what Alex gets if he throws a 2. If he throws a 4, it won't be sufficient. It'll either be less or more. So here we got 2, less, it will either be the same or less, sorry. Okay, so here we got to take This time Sam's scoring 5 and a 4 or a 2. So it's going to be a 0.2 plus 0.3. Okay. Plus 0.25. And this is multiplied by, when he gets a 2 here, which is going to be 0.25. Okay, so that those three combined should give you your answer. Okay, so let's have a look. We have 0.15 times 0.25 plus 0.3 plus 0.2. Okay, and then we're going to have plus 0.1 times 0.25 plus 0.3, which is 0.55. Okay, and then we're going to have plus, and then we're going to have 0.25 times 0.2, that's 0.5, 0.75, 0.5, 0.75. Okay, and that should give us an answer. 71 over 200 is an answer which rounds to what? 0.355. 0.355. And there we have. Okay, so that concludes this question. Question number 2 from the June 2024 International A-Level Statistics S1 paper. Other questions from this paper you can find in the playlist that will be appearing at the top right of the screen at the end of the video. Other questions from this topic of discrete random variables you'll find over here at the bottom right. You can subscribe to the channel by clicking on the link over here. And the video linked at the top will show you how to use my channel to find what you're looking for efficiently. Thank you for watching and see you soon.